In addition to day 3's word problem, I want us to look at these awesome fraction models. The first one says, look at this set of eating utensils. Okay, so we look at the eating utensils in the box. You see there's spoons, knives, and forks. The question reads, what fraction of this set are forks? So first thing that we need to do is determine the denominator. I am going to determine the denominator, remember the number that goes down below the fraction bar, by counting each of the utensils in the box. So you go ahead and count them to yourself as I count mine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because there are 12 eating utensils, that means that our denominator is 12. So the number below the fraction bar is 12. Now the question is, which set of these 12 are forks? So then we go back and we count the forks. And that is going to determine our numerator. So I have 1, 2, 3 forks. So our numerator is 3. So the fraction set using this model that are forks is 3/12. Now, if I want to dig deeper into 3/12, I would try to figure out, is 3/12 closer to 0/12, or is it closer to 12/12? Okay, and the answer is that it is closer to 0/12 because numerator 3 is only 3 jumps away from 0/12. It is 9 jumps away from the 1 whole, or 12/12. If we move on to the next question, here is a number line. It says, look at the number line below. What fraction is located at point X on the number line? Well, the first thing that I'm going to do is determine the denominator, right? So I'm going to choose 2 whole numbers. I guess I'll choose 0 and 1, and I'm going to count the segments in between each of the spaces. So this is 1, 2, 3, 4, 5, 6. So my denominator for this set is going to be 6. And that is the number that goes below my fraction bar. So now I need to locate point X. Now we can write this in 2 different ways. We can write it as a mixed number or as an improper fraction, or both. Well, let's first do the improper fraction. I'm going to count the segments from 0 all the way until I get to the X. That is going to give me my numerator for the improper fraction. Well, let's go ahead and start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my numerator is going to be 15. So my improper fraction is 15/6. I know it looks a little different from what we're used to, but remember, improper fractions means the numerator is bigger than the denominator. Now, we can also write this as a mixed number. Mixed number includes a whole number as well as a fraction. So the good thing is we can already determine our denominator because the denominator is not changing. Next, we have to determine which 2 whole numbers this X is located between. It is located between the 2 and the 3. Because it has already passed the 2 and has not yet reached the 3, we can determine that the whole number here is 3. So we write that in front of the proper fraction that we're going to write as our large whole number. Now we need to figure out which of these segments in between whole numbers 2 and whole numbers 3 marks X. So let's begin. So we have 1, 2, 3. So our improper fraction is 15/6, and our mixed number is 3 and 3/6. Well, what do we know about 3/6? Yes, we know that if the numerator is half of the denominator, then it equals 1/2. So our fraction really is 3 and 1/2, or we can write it as 3 and 3/6, or we can write it as 15/6. All right, if we move along to the set at the bottom, all right, so we have another fraction set here, and it says, in which group are exactly 3/8 of the shapes circles? Now, 3/8. 3/8 means that there are 8 shapes altogether, because remember, the denominator represents the total amount of shapes. So let's count the shapes in segment A here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So A has a denominator of 11, and we're looking for denominator 8, so that's not going to work. A is not a choice. B says, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, the denominator is 11. There are 11 total shapes. We're looking for 8 total shapes, so B is not a choice. That leaves us with C and D. And remember, we're looking for 8 total, but we're looking for 3 of them that are circles. So 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, let's write our denominator, sorry. 1, 2, 3, 4, 5 are circles, so 5/8, and that is not what we're looking for. So C is not a choice. Let us look at option D. 1, 2, 3, 4, 5, 6, 7, 8. Okay, is our denominator. And then there are 1, 2, 3 circles. So D represents 3/8, and D is our choice. All right, the last one that we're going to work with for today is another number line. So the question reads, what fraction is represented by point W shown on the number line below? So I'm looking at my whole number 0 and my whole number 1, and W is located in between those two whole numbers. I'm going to determine my denominator by counting the segments that lie between 0 and 1. So I'm going to begin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my denominator is 12. That means that I'm looking for a fraction that has 12 below the fraction bar. So A is not a choice, and C is not a choice. Now, I have to determine W, and I know that W is more than 1/2 because it's to the right of 1/2. If my denominator is 12, then this 1/2 should be 6/12. So I'm looking for a fraction that represents a number greater than 6/12. So let's count. 1, 2, 3, 4, 5, 6, just like we said, 7, 8, 9. So W represents 9/12. So D is not a choice, and our best answer here is B, 9/12. All right, guys, we will work on day 4 at another time. Hope you, if you have any questions, please give us a call here at the school or tell your parents to hit us up on Class Dojo. All right, take it easy.